So f prime tells us increasing, decreasing. F double prime tells us concave up, concave down. So that gives us a better idea of the shape of graphs. We will define a function as increasing if as x moves to the right, the y values go up. Okay, we know what increasing means. Like you read a graph like you read a book, left to right. As you move left to right, if it's going up, then it's increasing. Function's decreasing is as you move to the right, the y value goes down. The function is constant if as x moves to the right, the y value doesn't change. Okay, we're good here. Decreasing, constant, increasing. I hope that's definitely old news to you. Increasing curves come in three varieties as shown. In each case, let's draw tangent lines at points along the curve. So just pick maybe 3 points and draw a tangent line. It's kind of tricky on the first one, even though that's the simplest graph, because what does each tangent line look like? How do the tangent lines compare to the original graph? If I draw a tangent line, no, they're the same. Like it's hard to draw a tangent line because the tangent line lies right on top of the curve that's there. So it's the easiest curve, but maybe the weirdest one in terms of tangent lines. Three different tangent lines on that one. And three different tangent lines on this last one. What is true about the slope of the tangent lines at all of these points? So at all of those points, all 9 of those points that we drew tangent lines for, what's true about all of those slopes? And yeah, it's like, are you sure which, you know what they're asking here? But they're not changing for this one. Those slopes aren't changing. I think this question is easier than you're trying to make it out to be. F prime in all of those is positive. And of course that's means the same thing as f is increasing. But obviously there's something different about those three. And that's sort of what comes next. But we'll just leave it alone for right now. Next set. Decreasing curves come in 3 varieties as shown. In each case, let's draw 3 tangent lines at points along the curve. And again, on that first picture, it's tricky to draw tangent lines to a straight line because the tangent line is the straight line. So I guess you can do it, but you can't really tell that you did it. Especially considering that last blank we filled in. What is true about the slope of the tangent lines at all of those points? F prime is negative, which is the same thing as f is decreasing. I mean, those are the same thing, but it asks about the derivative, so we need to answer in terms of the derivative. So we know that already, I think. F prime positive is increasing, F prime negative decreasing. We can make the following statements about increasing and decreasing functions. Let f be a function that is continuous on the closed interval, differentiable on the open. By the way, that's sort of the, anytime we have continuous and differentiable, it's always continuous on the closed, differentiable on the open. F prime greater than 0 means f is increasing. F prime less than 0 means f is decreasing. If f prime is equal to 0, then f is constant. All right, that's old news, I think, I hope. It's supposed to be. When we examine functions that have curves to them, we'll define their curvature in terms of concavity. Concavity comes in two flavors, which I don't know, that seems an odd word choice there, but whatever. Two flavors, concave up and concave down. Again, today should be review. All of this should be like old news to you. We call this curve concave up. The term I use is holds water. If the water is poured into the structure, it will collect and hold the water. The problem with the hold water thing is that that's also concave up, but that would not hold water. So I get what he means. Just be careful. That's concave up, would not hold water. That's concave up, would not hold water. So be careful with the holding water thing. On the concave up curve, draw tangent lines at the point shown. What is true about the slope of these lines? Let's draw the tangent lines first. So little bitty tangent pieces. Don't draw the full line, because then you'd have a mess on your hands. But that next question is really important. What is true about the slopes of those lines as we move left to right? What's true about the slopes of those lines? Okay, they go from negative to positive. That's true. How else could we phrase that? That's absolutely correct. But what else could we say? Even if they didn't have a change of sign, what if we only looked at those? What would you say about those slopes? They're increasing. So the slopes are increasing. Well, another name for slopes is f prime. So we could say f prime is increasing. Increasing is a derivative word. That's a slope word. That's a rate word. So f prime increasing, that means the same thing as f double prime is positive. And of course, if f double prime is positive, that means we're concave up. In fact, we could make double arrows on all of those. All of those mean the same thing. So any three of those statements automatically imply the other two. Usually students have a good job of connecting the second two. Concave up, f double prime is positive. Like those get tied together in your brain. We got to make sure we include this last statement in there as well. If f prime is increasing, that throws in with all of those. That all means the same thing. Next one, we call this curve concave down. The term I use is spills water. If water is poured onto this structure, it will spill off. Again, yes and no, but you got to call it something. On the concave down curve, draw tangent lines at the point shown. We call this curve concave down. On the concave down curve, let's see, we did all that. What's true about the slopes of these lines as we move left to right? Especially as you compare it to the answer we just did. What are those slopes doing? Decreasing. They go from really positive to less positive to 0 to a little bit negative to a lot negative, the slopes are decreasing, which means that f prime is decreasing, which means that f double prime is negative, which means that that graph is concave down. Which we knew by looking, but we want to make sure we have all three of those ideas tied together. So we can define concavity as follows. If f is differentiable on an interval I, the graph is concave up. If f prime is increasing, and concave down if f prime is decreasing. When you think slope of a tangent line, you think, what would you put in that blank? I don't have a key for this worksheet, so I'm curious what the author thinks versus what you think. So what do you think goes in that blank? When you think slope of a tangent line, what did you say, Connor? F prime. Slope of a tangent line is f prime. I think that's what goes there. When you think increasing, do you think... This is a little bit why I took points off your test, Andrew. When you think increasing, it's like, well, what is increasing? When you think increasing, you should think so I'm gonna cheat and use the word I don't like to use here. When you think it's increasing, you should be thinking its derivative is positive. So here's what I mean. If f is increasing, that means that f prime is positive. And this is why its is okay here, because we can stick multiple things in there. If f prime is increasing, what does that imply? F double prime is positive. And we could keep going. If the fifth derivative is increasing, I have no idea what that means in terms of the graph, but if the fifth derivative is increasing, what does that mean? The sixth derivative is positive. That doesn't really serve us any purpose, but that tries to emphasize that if something is increasing, its derivative is positive. And then same thing for decreasing. When you think decreasing, you think its derivative is negative. You don't have to go through the fourth and fifth and sixth derivative stuff, but if f is decreasing, f prime is negative. If f prime is decreasing, f double prime is negative. Those go together. We are talking derivatives of derivatives, which means second derivatives. So concavity is related to the sign of the second derivative. Again, most of this is review. If the second derivative is positive, then the graph is concave up. Second derivative is negative, the graph is concave down. Straight lines have no concavity. Straight lines have no concavity. If you think about why that is, it's because their second derivative is zero. Like the first derivative would be their slope, but the second derivative would be zero for a straight line. When you know f prime and f double prime, you can determine the shape of f of x. We've done a little bit of this. Let's see if we can draw a piece in here in each of those 9 boxes. F prime is positive. What does that mean about f? Let's put something else in here. F prime is positive. What does that tell us about f? f is increasing. If f prime is negative, then f is decreasing. If f prime equals 0, what does that mean? There's a couple things that could mean. If the derivative is 0, it's constant. So it could be, if f prime is 0 for a while, then it's constant. If f prime is 0 for just an instant, then it's like a horizontal tangent line. Not like, it is a horizontal tangent line, or has a horizontal tangent line. All right, down the left side, f double prime greater than 0. That means concave up. F double prime less than 0. Concave down. F double prime equals 0. What would you say there? Possible point of inflection. In fact, we could have added the first derivative equivalent to that on f prime equals 0 into critical points. So f increasing, concave up. Increasing, concave up. Something like that. We've drawn these little pictures before. Increasing, concave down. Increasing, concave down. Increasing with an inflection point. So this is a little bit trickier to draw maybe, but I want to be increasing the whole way, but I want to change from concave up to concave down. So at that spot right there. And you could have done it the opposite way. You could be going from concave down to concave up. So somewhere in there. Is an inflection point. All right, decreasing, concave up. So decreasing, but concave up. Decreasing, concave down. Decreasing, fold down. Decreasing with an inflection point. See if you can draw those two spots. I'll hit pause. So draw the two possible pictures for this box. So both of those are decreasing. This one changes from concave up to concave down. This one changes from concave down to concave up. Let's see, if f prime is 0 and f double prime is positive, well, they kind of gave away the answer there. So concave down, but horizontal tangent line makes a concave up. Should read more carefully. Makes a minimum. Concave down with f prime equals 0 makes a maximum. By the way, those two boxes, that's the second derivative test. F prime equals 0 and f double prime is positive versus negative, then you can make a decision about relative max and relative min. If they're both equal to 0, then you've got a horizontal tangent line and a possible inflection point. So it like levels off and then goes up again. Something like that. Or the other way, I guess. Levels off and goes down. Y equals x cubed has one of those points where f prime is 0 and f double prime is 0. All right, this graph looks terrible, but it's really not that bad. We've done something kind of like this where I gave you a whole bunch of points and you had to answer about them. For each term, determine if it's applicable at the x values a through m. So all we're going to do is put like a check mark there. So point A, is that a critical point?
No.
Why not? That one's kind of iffy because it's an important point because it's an endpoint, but it's not a critical point. So no, but man, that's kind of a tricky one. You know what? Let's do A, B, and C kind of together here. I don't want to do all of them though, because I want you to do some of them. How about B? Is B a critical point? Yes. All maxes and min, all relative max and mins are critical points. So that's a yes. In fact, we could even say because f prime equals 0. How about C? Is C a critical point? So it's a good question. Is it a point of inflection? I don't know. If it's a point of inflection, would that make it a critical point? No. What would make it a critical point is if it's a vertical tangent line. So kind of a question mark on that one. If it's a vertical tangent line, what's the derivative at a vertical tangent line? What's the slope of a vertical tangent line? Undefined. So that might be a critical point if that's a vertical tangent line at C. All right, let's move over to relative minimum. Are A, B, or C a relative minimum? Relative minimum. A, B, C? No. A, B, C a relative maximum? B is, yeah. A stationary point is, and we haven't used that word before, is where f prime is 0, so where it's not changing at that moment. So A, B, and C, is any of those stationary points? B is. Its derivative is 0. Inflection point, you know what, let's back up here. We should have done this from the get-go. The critical point is f prime equals 0 or f prime undefined. Relative minimum, that would be at the valley, the bottom of the valley. Relative maximum, top of a hill. Stationary points, f prime is 0. Inflection point, what's the summary for what an inflection point is? Change in concavity. How about absolute minimum? What's the easiest way to say that? What would you be looking for? Very bottom, yeah. Lowest point. And maximum would be the very tallest, highest, greatest. Yeah. Any inflection points from A, B, and C? C, yeah. It changes from concave down to concave up. Is there an absolute minimum among A, B, and C? No. Is there an absolute maximum between A, B, and C? Yeah, I think B is an absolute max. So just going through points, thinking about first derivative, second derivative, concave, that sort of stuff. Number 2, you're given a graph of f prime. This is the graph of f prime, not the graph of f. This is the graph of f prime. Let's see, f prime tells us the slope. Well, this is an interesting graph. What's f prime equal to in this graph the whole way? -3. What does that tell me about the graph of f? slope of f equals negative 3. I don't know where to start, right? It didn't give me it's called an initial condition, like how do I know where to start the graph? So start wherever you want. If you start at 0, then your slope is down 3 over 1. That's why it says possible f of x. Because you could also start over here at negative 4, 0. As long as you go down 3 over 1, that's a possible graph of f. That was kind of an easy one. Let's do a harder one. Let's see. F prime. Let's see. What would you say about f prime up to 1? What would you say about f prime? It's positive over there. What does that mean about f? If f prime is positive, then what's f? F is increasing. What would you say about f prime over here? It's negative. What does that say about f? Decreasing. So we go from increasing to decreasing. F goes from increasing to decreasing. What about, say something else about f prime on this side of things. So I know it's actually the whole way. F prime is decreasing the whole way. If f prime is decreasing, what does that tell me about f? It's concave down. So I'm concave down the whole way. And at 1, at x equals 1, I change from increasing to decreasing. So actually, what is going on at x equals 1? A relative maximum is there. Because f prime changes positive to negative. So I don't know where the max is. Somewhere I got a max. I need to be increasing up to that point, decreasing after that point, and concave down the whole way. So increasing but concave down, and then decreasing concave down. It's a possible graph. There are other graphs. Like if you thought the maximum was here, and maybe it was a little steeper, like that's also an acceptable graph. Because we don't have enough information to get it exactly right. All right, C. Let's see if we can finish this one. And your assignment will be the rest of them. What would you say about f prime almost the whole way here?
Positive.
It's positive. That means f is increasing the whole way, except for at x equals 0. It's like the slope is 0 there, but it's positive. Other than that, it's increasing the whole way. What else could you say about f prime on this side? Okay, so f prime is decreasing, which means, what does that mean about f? Concave down. And then on the other side, f prime is increasing, which means f is concave up. And if we change concavities, that's a point of inflection at 0. So I don't know where the point is, but I know at 0 there's a point of inflection. I need to be increasing the whole way, but I need to be concave down on this side. Increasing the whole way, concave up on the other side. Something like that. All right, your job is to try D and E. D is going to look really similar to C because, I mean, their graphs are pretty similar. So D is going to look really close to C. E, you got a lot of stuff going on in E. So 2 problems, try both of those. Again, you're thinking, is F prime positive or negative, and is F prime increasing or decreasing? And that will tell you if F is increasing and if F is concave up, concave down. So you kind of put it all together and sketch a graph.